All right, so welcome back. We're going to continue on with Unit 2, or Unit 1, I'm sorry, Unit 1, Section 2. We're going to finish up Section 2, which is going to deal with unit conversions, taking kilometers to meters and centimeters to meters or meters to centimeters, so on and so forth. Okay? Some of you, most of you have done this already, so it should be a review, but it's a good skill practice, and we will try to do as much practice as we can. So again, starting with the do now, suppose one of your classmates estimates that she drinks 3 gallons of water in a week. Another classmate thinks that he drinks 350 ounces of water in a week. Who drinks more? What do you need to know? And what would make this problem easier? Well, you need to convert them into like units. Okay, unless you're really good with ounces compared to gallons off the top of your head, and some of you may be. Um, then you need to get them in the same units. Okay, gallons is a unit of measurement, ounces is a unit of measurement. Okay, so whether you're moving decimals to go to small or large units of measurement, or you're converting English to metric or metric to English, there's ways to go about it. Okay, so units of measurement. Scientists use the standard units of measurement, also known as we use the International System of Units, which is the SI system. This set of standard measurements lets us compare observations and calculations with scientists across the world. We're going to talk about a situation towards the end of this lecture where these common types of measurements were not used and mistakes were made in the conversion factors, and it resulted in a lot of money lost in a tragic event. All right, so the base units of measurement. So when we talk about here in a minute about unit conversions, you're going to see units or U as one of the steps on the ladder, how I teach it. So these are the base units, okay? For length, meter is a base unit of measurement, and its abbreviation is there. For mass, it's kilogram. Time is second. Temperature is Kelvin. Electric current is an ampere. Amount of a substance is a mole. And the luminous intensity is a candela. All right, so we will focus mainly in the top two. Okay, top two. We will do some liter stuff as well. Maybe a little with seconds there, and maybe a little with temperature as we move through the course. So derived units. So what about area, volume, pressure, weight, and speed? All of these quantities are measured in derived units. So a derived unit is a combination of base units. So for example, area is length times width, and then the units of measurement are always squared. Volume is length times width times height, and volume's unit of measurement is always cubed. So some prefixes for some large measurements, and I'm going to give you a unit conversion sheet. I'll attach it to this week's assignment link, and that one's yours. You can download a copy of that or put it to your Google Drive and keep it. And it's just a stair-step ladder, which will help you. So kilo, mega, and giga. Now, there'll be some that we do when we get out into this world, but the rules change when we get here. It's actually going to move 3 times as much as it does from kilo to hecto to deca to units, so on and so forth. So small measurements. You have deci, centi, milli, micro, and nano. And we kind of hang out in this course in the deci, centi, and milli world. Okay, micro and nano. We don't really get down in there much again because the rules change. And this is not the exact signal for or symbol for micro. It's kind of there's a line that drops down right here, almost like a P, but it doesn't connect at the top. It's a little weird little symbol. All right, so I will post a short video here in a minute that will show how these two problems are going to work based off what I provide you as far as a conversion sheet, and how I think it's easier to do this instead of using a calculator if you don't have a calculator. So take mental note of these. When I do this problem in a minute, I'll say we're going back to the class practice slide, and I'll pull this up and we'll do it. So we said earlier what we would talk about why it matters. So a $125 million space probe, the Mars Climate Observer, crashed on Mars in 1999 because key numbers were calculated by one group in English units while another group used metric units. The difference was not clearly communicated between the groups because critical maneuvers necessary to place the spacecraft in a proper Mars orbit relied on calculations involving numbers from both groups, and conversions between the two systems were not applied. The probe crashed and was destroyed. So $125 million was lost because the conversion between English to metric and metric to English is not simple. Okay, almost have to have a cheat sheet, so to speak, in order to do this. So this is why we, in the science world, we use the standard issue or the SI units now, the metric unit in the science world as well. So this type of thing does not happen again. So kind of rounding out this particular lecture, a couple of vocab terms, weight versus mass. It's very common for people to get these two confused, so we need to discuss the difference between them. Mass is a measure of the amount of matter in an object. Weight is the measure of the gravitational force exerted on an object. Okay, so the how I kind of describe this in person or in class is my mass, whatever my mass is, it's the same on Earth as it is on the moon as it would be on Mars. Okay. My weight, however, will change based off where I'm at. Okay. My weight may be one thing on Earth and it will be different on the moon and it may be different on Mars because the amount of gravity acting on me is going to be different in those three places. So that changes my weight, but my mass stays the same. So if I'm 200 pounds on Earth, I may be 130 pounds on the moon. I didn't lose mass. The amount of gravity working on my body changed, which changed my weight. So to kind of finish this up, think about it. So an old riddle asks, which weighs more, a pound of feathers or a pound of lead? So I normally ask this question in class, and at first everyone is just typically, I mean, you have a few that catch on pretty quick, but at first everyone's a pound of lead, pound of lead, pound of lead. But read it again, a pound of feathers or a pound of lead. Okay, it's the same. You'll have a lot more feathers than you will lead, but at the end of the day, it's going to be a pound. Okay. All right. Now, where the gravity kind of acts on it may change things in certain situations. But if we're going to do a pound of feathers, pound of lead, then it's a pound nonetheless. And that is going to be where we stop. Okay. Be sure you complete the form with this video, and also be sure you catch the next video, which will be the class practice problems.